Okay, this time we will start to develop an application from scratch using GeneXus. This application will look similar to the EventDay application we've been talking about. We're using GeneXus 15 and don't have any KBs opened. We will start by creating a new knowledge base called EventDays. We will create it by prototyping in C# in this folder here. We click on Create. Now, when the knowledge base creation is complete, we will see all the folders and modules that will be automatically imported into this KB. We will also see the domains that will be automatically created and so on. Now it's finished. Note that a root module has been created. It contains a GeneXus folder with two other folders. Common, with an external object called Global Events that will be mentioned later on, and a web folder that will implement the master page, in addition to other objects for the web part of the application we develop. On the other hand, let's look at this references node that is displayed in the little tree and contains a GeneXus module with a group of submodules, client, and common. Let's look closely at this one, SD, which contains a group of external objects and SDTs that will be used by our application for smart devices when interacting with the various features of the device. The interesting thing about this node, and what should be noted, is that everything inside here will be read-only. That is to say, it cannot be changed. Here we can see that it says read-only. In fact, it'll be implemented when we generate our application. When we generate it in the various stages of the prototyping process, these objects will not be generated again because they will already exist. That is to say, the binary files will already be incorporated. This is one of the greatest advantages provided because the generation time will be optimized. Let's begin by looking at the default domains, which are integrated into the KB when it's created. We can see that there are several domains. In particular, there's an address domain, an email domain, and a phone domain, for example. All these domains will be known as semantic domains, because they will contain semantics that will allow making certain actions when the domains are found. We will see this in a moment when we prototype the application. On the other hand, we will want to prototype our application in the cloud, not locally. Because in this way, we avoid the need to have the entire software, database manager, and so on in our file system in our network. So we select Generators and click on the web generator of our environment. And there we will find, at the bottom, the Deploy to Cloud property, which is set to No by default. We set it to Yes. We see the deploy server URL is displayed, along with the virtual folder. From now on, we will not worry about the software or the database anymore because they will be managed in the cloud. We have for now only one generator in our environment, the default generator, which is C# because we selected it. So let's start by creating two transactions. The first transaction will be used to store or record the countries where the speakers come from. So, we will add a country ID attribute as identifier, set it as an ID domain, numeric of 8, we will set this country ID as auto-numbered, so we open the auto-number property of the attribute and set it to true. The domain will not be auto-numbered. We can actually open the Domains tab and see that the new domain we've added is now displayed in bold. The default ones are in gray. We will create country name as well as a domain called name of varchar type of 20. Lastly, country flag will be of image type. We save. Next, we will create another transaction, the speaker transaction, to record the speakers of our event. Speaker ID identifier. Next, we enter speaker name for the speaker's name of name domain, speaker surname of varchar domain, this time of 40. We will create a formula attribute, speaker full name, of varchar type 60. We define speaker surname and apply the trim method to remove the blank spaces. Leave a blank space and end with speaker name. Trim again to remove the blank spaces. Next, we define the formula attribute, and then we define the speaker image attribute to save the speaker's photo. Speaker CV Mini, Curriculum Vitae Mini, which we set as varchar of 1024. In addition, we will enter the speaker's country ID, and its name. Also, we will enter a phone for the speaker and see that when I press Tab, phone, GeneXus is displayed. This is the phone domain, which is a semantic domain, as we will see, inside the GeneXus module that we had already talked about. Good. We also add speaker address and speaker email, and see that the same happens. We save. In addition to this structure, we will want to add some rules to prevent, for example, the speaker name from being empty. We don't want the speaker name to be empty, which is why we trigger this error. So we'll write if, insert the speaker name attribute, if speaker name is empty. In addition, we will want to do the same about the speaker's last name. We don't want it to be empty either. So we throw an error if speaker's surname is empty. Lastly, we will display a message rule. It will not be an error displayed when the resume is empty. Instead, it'll be a message, and we will not prevent a record, a speaker, from being saved if the resume is left empty. We will just inform the user that it shouldn't be empty. We save, and there are two transactions. If we start developing the web backend of our EventDay application, the first thing we would like to do is apply the work with for web pattern to these two transactions. How did we go about applying the pattern? Let's review this. We opened the country transaction and selected the Patterns tab. There, we found the Work With for Web tab and selected this checkbox. And after saving, the instance file would be generated. This file determines the information that will be displayed in the work with object. That is to say, it's customized. In addition, the objects that implement each part of the work with object would also be generated, the list and the view. So, if we double-click here, we see that we have the instance file, which is not an object. It's part of this right here, the transaction. And below, we have the objects implementing this pattern: GeneXus object, web panel, web component objects, and so on. In addition, the same goes for speaker. We could do the same, or directly by right-clicking, Apply Pattern, Work With for Web. So the Work With pattern will be automatically applied to this web transaction. Here we see the instance file and open it. The instance file can be opened independently, both within the transaction from the Patterns tab and independently. Okay, we have the Work With object applied. Now, we will set auto number to true for speaker ID. We will want to run the web application, this sort of back-end web that we're starting to build. Something that happened automatically when we applied the pattern was that new objects were created inside the web folder, including the home object, which will call these two work with objects by default. There, it'll implement the invocation automatically. The programs to be called will be loaded in this list programs. They will be both work with objects and they will be displayed there. Also, I will want to initialize these transactions with data. I don't want to do it manually because I don't want to waste time entering its values. As from GeneXus 15, what I would do to initialize these transactions with data would be to open the transaction itself and set the data provider property to true. Then, leave the use_to property to populate data, because that's what we want to do, populate with data. After saving, a data provider associated with the transaction would be created. There, in that data provider, we will state how it's loaded and what records will be loaded in that transaction. This would only be invoked when we pressed F5 for the first time. Thus, when the database is reorganized, this data provider will be invoked to automatically load the table with data. I will not do this because we don't have enough time, and I had data already loaded in the traditional way. I will import two procedures that do the same. So in XPZ, I will look for an XPZ file. And this XPZ file will load these two procedures to initialize these two transactions, the tables with data, and will load the images of the country flags and the speakers. I import. We're doing it in this way only because I had already done it. The idea would be to use the data provider associated with the transaction. The import was successful, so now I will just invoke them from home in the start event. Initialize countries, and initialize speakers. We save. So now, we want to try the web backend and then start developing our smart device application. So I'll just press F5, and we'll read this output window. So it's asking us to reorganize the database. Where is it reorganized? In the cloud. It's starting to generate the C# programs. Here, it's starting to reorganize. The speaker table and the country table have already been created. The specification begins. Here we see the navigation list, which shows the navigations made. The application starts to be uploaded to the cloud, and we're informed of the bytes remaining. It starts to run. It's now complete, and we see that the developer menu has been opened, with the home and the two work with elements we had. If we select home, the start event will be run to invoke these two procedures to initialize the objects with data. Here, the countries are loaded. And here we have the speakers. So, we said that we had done the following. We had applied the work with for web object to both transactions. And now we will do the same, apply the work with object, but this time for smart devices, and we'll see what happens.